Ladies and gentlemen, we will finish what we started discussing on Thursday. We started talking about key features of a graph, a polynomial graph, and we started discussing these questions. Where is the graph increasing? Where is it decreasing? Positive and negative values, relative maximum, minimum, symmetry, end behavior, and solutions. Now, we started on Thursday talking about increasing and decreasing. By increasing and decreasing, we mean reading the graph from left to right. Where does it look like we're going uphill and where does it look like we're going downhill? So we're increasing from here to here and from here to here. So from -3 to about -1.5, we're increasing. So we'll say -3 and we're talking about the interval here in terms of x. So we're talking about the x values from left to right. And so we're increasing from -3 to -1.5 and from 1 to 2. We're decreasing from -infinity to -3, from -1.5 to 1, and from 2 to infinity. So, we talk about infinity when we see the graph going off the page. We can be going into infinity in either direction. And so from -infinity to -3, from -1.5 to 1, and from 2 to infinity, we are decreasing. Now, the question of positive and negative values is different from increasing and decreasing. We are positive from -infinity to -3, and from -3 to 0. So from -infinity to -3, and from -3 to 0, we are positive. That means above the x-axis. That means the y values are above the x-axis. Now, we are showing negative values any place where we are below the x-axis in terms of y. So from 0 to 2, and from 2 to infinity. And we also talked about relative maximums and minimums on Thursday. By maximum, we mean any place where the graph peaks, where it changes direction from up to down as you go left to right. So these are relative maximums. The relative minimums are where you have a valley, where you bottom out. Now remember that we use the term relative, meaning it's the highest point compared to the points around it, but it doesn't necessarily mean it's the highest point on the whole graph. If we had, say, a parabola that looked like this, and we could say this is the highest point on the whole graph, we would call that an absolute maximum. Now, we did not talk about symmetry on Thursday. This is where we're going to pick up where we left off. Symmetry would be if we had some kind of mirror image across one of the axes and or across the origin. This graph has neither, so the answer is no. If we had, say, a parabola and it was mirror image from one side to the other of the axis, that would be symmetry, but we don't have that. So there is no symmetry for this graph. We'll discuss some other graphs later that do have symmetry. What is the end behavior? End behavior means as the x value goes into infinity in one direction, what does the y value do? It could be going into infinity in either direction, or it could be going toward an asymptote, but in this case, we are going into negative infinity in terms of y. The y value is increasing in the negative forever off of the page. And so we say that as x approaches, that's what that arrow means, approaches infinity, y approaches negative infinity. Now going the other way, we're going into positive infinity in terms of y as x is going into negative infinity. So as x approaches negative infinity, y approaches infinity, positive infinity. Now, what are the solutions to the function? By solutions, we mean the x-intercept, or sometimes we call them zeros. And that would be where the graph touches or crosses the x-axis. So we have solutions at x equals -3, x equals 0, and x equals 2. And there you have it. Take a look at this graph, and when we come back, we will talk about the answers to those questions for this particular graph and others. Have a great weekend.